We're going to look at some examples from section 8.1. I'm going to do some monitoring progress questions with you. This is going to be really helpful when you do your big ideas assignment for classwork today. So we're going to start by looking at a monitoring progress question that goes with example 1. In example 1, we were identifying characteristics of quadratic functions. We're going to look at monitoring progress number 2. So just so that you know where I am, I'm in the textbook here on page 421. I know you don't have an actual book, but if you go in the online textbook, you can see what I'm looking at here. But we're going to look at monitoring progress number 2. So in number 2, we want to identify characteristics about this graph here. Again, we're looking at number 2. The first thing that I want to find is the vertex. The vertex is this point right here on the parabola where it starts to change direction, or where this U is happening. This point is -3, 7. There's our vertex, -3, 7. Next up is the axis of symmetry. The axis of symmetry is the line that passes through the vertex, and it's going to cut our parabola in half. So when I draw it in on my graph, I'm going to draw a dotted line because it's not really there, it's just kind of a visual effect. Let's look at where does this dotted line cross the axis. It's crossing the x-axis here at -3. So that means that the equation of this line is going to be x equals -3. Okay, next up we can talk about the domain and range of the graph. Our domain is all the x's going left and right. So since it can really be any x, that means our domain for this graph is all real numbers. You can write it out in words here, all real numbers, or you can use the symbol that we've been using that stands for all real numbers, this double block R here. Or you can write it out in words, all real numbers. Next up is our range. The range is not all real numbers, and it depends on the graph. If you look at our graph here, you always want to start at the vertex and then go towards the arrows on the parabola. So we're really going below this vertex point. Remember, the range is the y's. So I want to look at the y of the vertex, which here is 7, and the y's are going below it. So it can be 7 or it can be below. So our range is y is less than or equal to 7. Next up is our behavior. For the behavior of the graph, we need to talk about the left side and the right side of our graph. So for the left side of our graph, we're going to think from this axis of symmetry to the left. Our axis of symmetry was x equals -3. Let's go to the left of it. So when x is less than -3. So notice how I'm going to the left. When x is less than -3, let's follow from the vertex towards the arrow. My pencil is going down, so our y's are decreasing, and we're talking about the left side. When I go to the left, the x's are decreasing. So as the y's decrease, or I should say the y decreases as x decreases. Okay, let's look at the right side of the graph now. So again, we're going to go from this axis of symmetry to the right. So our axis of symmetry was x equals -3. We're going to do now when x is greater than -3 because we're going to the right. Now go from the vertex towards your arrow. Again, my pencil is going down, so the y's are decreasing, but now we're moving to the right, so our x's increase. So the y decreases as x increases. And that's our example, our monitoring progress number 2. Okay, next up we're going to look at graphing our parabolas, and that goes along with examples 2 and 3. And remember, now we're graphing them with a number, our a, in front of the x squared. So the number in front of the x squared stands for the a value, and that's going to change how the parent function is going to look. And we're going to do monitoring progress number 3. So here it is over here, monitoring progress number 3, g of x equals 5x squared. So I already wrote it down here on my paper. G of x equals 5x squared. We're going to graph the function and we're going to compare the graph to f of x equals x squared, which is the parent function of the parabola. So the first thing we're going to do is we're going to make a t-table. So we need to have our x values and our y values. When we make our t-table, we want to have 5 points. 5 points really make a good looking parabola. So I'm making my t-table with 1, 2, 3, 4, 5 spaces. In the middle, I'm gonna put 0 for my x because I know that that's gonna be the middle of my parabola. Now I'm gonna go 2 numbers down and 2 numbers up. So since this number is bigger than 1, I'm just gonna go by 1s on my t-table because that's what makes sense. So let's go down by 1s, -1, -2, and we'll go up by 1s, +1, +2. We're gonna take these x values, we're gonna plug it in here, we're gonna see what they equal. So -2 squared is 4 times 5 is 20. -1 squared is 2 times 5 is 10. Sorry. -1 squared is 1 times 5 is 5. 0 squared is 0 times 5 is 0. 1 squared is 1 times 5 is 5. And then 2 squared is 4 times 5 is 20. So I want you to notice how our numbers in our table are symmetric. The 20 goes with 20, 5 goes with 5, 0 is in the middle. Our parabola is a symmetric U, and so should our t-table be symmetric. So make sure you're always looking out for that. I want to show you that you can also get these values in your graphing calculator. So let's grab our graphing calculator and let's find these t-table values in our calculator. So here's my graphing calculator, and I'm going to go into y equals and put this equation into y equals. So in y equals, I'm going to type in 5x, remember x is this button here next to the green alpha key, squared. To get to the table, I want to hit second, and then the graph button here is the table. Okay, if you need to, scroll up so you can see when x is -2, and let's check our table. -2 is 20, -1 is 5, 0 is 0, 1 is 5, 2 is 20, so we got our table correct, which is great. Okay, our next step is now we're going to graph these on a coordinate plane. So I'm going to do it on graph paper. If you have graph paper, that's great. If you don't have graph paper, then you can just draw a coordinate plane in your notebook. That's totally fine, I understand. So on my graph paper, I'm gonna have my x's go by 1s, but for my y's, I think it makes sense to go by something bigger than 1, just because of how big these numbers really are. Maybe I'll go by 4s. I think that might be a good idea, or even 5s. 5s would be a good idea too. Let's go by 5s, I think that makes more sense. So again, on my x's, I'm gonna go by 1s. And for my y's, I'm gonna go by 5s. So this is 1, 2, 3, -1, -2, -3. For my y's, I'm gonna go by 5s, 5, 10, 15, 20, 25. Okay, let's plot these points on our coordinate plane, and I'm getting the points from my table that I created over here. So -2, 20. -1, 5. 0, 0. 1, 5. 2, 20. Then I'm going to connect these points and draw a smooth curve to connect them, and it should look like a U, and we're going to put arrows on both ends. Okay, let's check this graph in our graphing calculator. So go back to your graphing calculator. We should still have the table pulled up here, and all you have to do now is hit graph. And just keep in mind that our graph, our y's went by 5s. This graph, the y's go by 1s, so it's a little bit more elongated, but it definitely does look like this. So I know that I got this correct. Okay, our last step in the directions is we want to compare the graph to the graph of the parent function. Remember that the parent function is just y equals x squared. But what we're looking at now, the new function is y equals ax squared. So we want to look at this a value, and that's going to tell us about what's going to change about the graph. In this problem, our a is 5. So since our a value is 5, since this number is bigger than 1, it's causing our graph, our y's, to grow a lot faster. Look at how big these numbers got here towards the outside. So because of this number, since the a is greater than 1, since the a is greater than 1, that's going to cause this to be a vertical stretch by a factor of 5. So whatever the number is, that's what the factor is going to be. Okay, and that is number 3. Let's do one more example like this so that we can get the hang of it. We're going to take a look at monitoring progress number 8. So I'm going to take a second. Let me write down this function here. We have g of x equals negative 1/4 x squared. Okay, we're going to graph this function, and then we're going to compare it to the graph of our parent function f of x equals x squared. All right, so our first step is we're going to make a t-table just like how we did before. So we're going to have our x and our y. We're going to have 5 spaces in our t-table. And we're going to put 0 in the middle for our x's. Now, I could go by ones on this if I wanted to, but my y's would end up being decimals, which is totally fine if that doesn't bother you. But I think it makes more sense here to go by something other than 1 because of this fraction. Look at the denominator. You see how the denominator is 4. I could go by 4s, I could go by 2s, and that's up to you to decide whatever you think best. I think I'm going to go by 2s. That's my decision. So I'm going to go by 2s here. Let's go down by 2, so -2, -4, and we'll go up by 2s, +2, +4. Let's find these y values by taking the x's and plugging it into our equation, or you can use your graphing calculator. Let's do it by hand first, and then we can check in the calculator. So -4 squared, that's +16, times -1/4, that's -4. -2 squared, that's +4, times -1/4, that's -1. 0 squared is 0, times -1/4 is 0. 2 squared is 4, times -1/4 is -1. And then 4 squared is 16, times -1/4 is -4. Let's double check this in our graphing calculator how we did before. So we're going to go back to y equals. Let's clear out this equation in here, and let's put in our new equation. So our new equation is -1/4, so you do 1 divided by 4, x squared. Okay, we're going to hit second, and then table, which is above the graph button. And I need to scroll up a little bit more so I can see -4 is -4, -2 is -1, 0 is 0, 2 is -1. Let me scroll to see the last one. 4 is -4, so I know I got it right. Okay, my next step is now we're going to graph. So let's go